very warm welcome to WsCube Tech. So guys, in our previous session we have covered functions related to creating arrays. In our today's session we will be talking about more functions. Let's have a look on what all functions we will be studying in our today's session. So our first function over here is flatten. The flatten over here says that by using flatten, if suppose we have two arrays which is like this, 1 comma, no, the comma is not there because it's an array. So 1, 2, 3 and 4, and if I have another array as 1, 4, 3 and 2. Okay, and if I use the flatten function to it, then what it would do, it would flatten this in this format, that it would give me a new array in the format of 1, 2, 3, 4, 1, 4, 3, 2. That means it will flatten it into one dimension over here and it will give us this array, and right after this it will append this array to it. Okay, so there is this one method, and there is another thing called as axis over here. So axis over here is what? Axis over here tells us that if the axis is equals to 0, then it will flatten it vertically, and again if the axis is equal to 1, in that case it will flatten it horizontally. Now what is flattening horizontally over here means? Suppose if right now we are flattening it horizontally, that means the default value is 1. So that means we are going on this array first. That means first we are writing 1, 2, 3, 4. Then horizontally we are going for the second one, that is 1, 4, 3, 2. But if I would have given axis 0, in that case it would have flattened it to first this element, that is 1. The second element would be this one. The third element would be 2. Then 4. Then 3. Then 3. Then 4. Then 2. That means it will vertically flatten. That means it will go this way while flattening it. So this is what our axis would do over here. Let's move ahead and talk about our next function, that is the sum. This function is used to compute the sum of all the elements. Suppose if you have all the elements like this, suppose you have, I'll take the same example of 1, 2, 3, 4 and 1, 3, 4, 2. Okay. So if I put sum over here, then what it would do, it would give me, if I put it in the axis as vertically, then it would give me the sum of these two as, first one would remain the same, that 1, 2, 3, 4, and the second one would be 1 plus 1, that is 2, 2 plus 4, that is 6, 3 plus 3 again 6, 4 plus 2 again 6. Okay, this is how it would give me a sum. And if I would have given it horizontally, in that case what it would do, it would add both of them. So 1, 2, 3, 4. So 4 plus 3 is 7 plus 2 is 9 plus 1 is 10. So in that case it would give me the first element as 10, and the second element over here would be 4 plus 3 plus 2 plus 1, again it is 10. Okay, no comma but just 10 over here. Okay, so this is how an axis over here makes a difference. That axis over here, 0 means that vertically we will be adding it, and horizontal, and if you want to add something horizontally, in that case you will be using axis equals to 1. Next, let's move ahead and talk about nansum. Now what is nansum? This function is used when we want to compute the sum of array elements over treating not a number nans as 0. Now what does this thing mean? Suppose if we have a 0 element over here, that means if we have a null element, not a number element, suppose instead of 1, 2, 3, 4, this is our array, and instead of 4 I have np.nan. Nan means not a number. So suppose in a case we don't have a number over here, we have only 1, 2, 3 and we don't have a number over here, we have np.nan. In that case our nansum is used. Other functions that we have over here are exactly same to our sum. That means we can put axis to 0, axis to 1, that is totally up to us. In this case what would happen? In this case it would give us np.nan, but in our nansum case it will treat it as 0 and give the output as 1 plus 2 plus 3 plus 0. Similarly, if we talk about going vertically, in that case it would give us 3 for this one, 6 plus 2 is 8, 6 plus 3 is 9, and 6 plus 0 as 6. Okay, let's move ahead and talk about our next function, that is cumprod. It is used when we want to compute the cumulative product of an array. Suppose if you want to compute the product of an array, in that case cumproduct is used, and here again axis is used. And similarly we have cumsum over here. That means it will compute the cumulative array for us, cumulative sum for us. So if I have written anything like 1, 2, 3, 4, and here I have written 2, 2, 1, 2. Okay, these are my two arrays, and the cumproduct will give us, if I go horizontally, it would give us 1 multiplied by 2 multiplied by 3 multiplied by 4. If I talk about cumproduct, it will give us cumulative product in this way, that the first element will remain 1. The second element will be the multiplication of these two, that is 2. Third element will be the multiplication of this one, and this one, that is 3 multiplied by 2 is 6 plus multiplied by 1 is 6 again, and 6 times 4 is 24. That would be our last element. And for the second one it will do the same, that the first element would be 2. The second element would be 2 multiplied by 2, that is 4. The third element would be 2 multiplied by 2 multiplied by 1. So that would be again 4, and 2 multiplied by 2 is 4, multiplied by 1 is 4, and multiplied by 2 is 8. So this is how we will obtain the output if we go horizontally, and if we go vertically, in that case the first row will remain the same, the second row will be the multiplication of it. So 1 multiplied by 2, 2 multiplied by 2 is 4, 4 multiplied by 1 is 3 multiplied by 1 is 3 over here, and 4 multiplied by 2 will give us 8 over here. Okay, this is about cum product. If I talk about cum sum, in that case the same thing would happen, but instead of product it will find a sum over here. Now let's have a look and see how these functions work in our NumPy arrays. So first of all, to use NumPy arrays, I'll be writing import NumPy as NP. Once I have imported NumPy as NP, I'll be creating two lists over here. So N1 is the odd and even number, so 2, 4, 6, 8. Once we have created N1, we'll create another list over here that is called as N2, and inside here I'll be putting some and random elements like 1, 3, 5 and 7. Okay. Now to create an array over here, what we need to do, I'll be giving a variable called as n. Inside the n, I'll be writing np.array, and here in the format of a list, I'll be passing my n1, n2. Once we have put this, we will be writing print statement, and inside this, I'll be writing n, and as soon as we run it, we'll get the output as 2, 4, 6, 8 and 1, 3, 5, 7. So this is what? This is our two-dimensional array where we have 2 rows and 4 columns. Now if I want to flatten it, what I'll be doing, I'll be writing n.flatten, and as soon as I run it, I'll get the output as 2, 4, 6, 8, 1, 3, 5 and 7. So that means you can see we have got the first row over here, then we have got the second row, that is 1, 3, 5, 7. So I'll just print this way also. So I'll be writing print and write n inside it. And if I run it, so our first array over here, that means first of all we'll get it in the 2 dimension. Once we have flattened it, we'll get the output in this format. That first we'll obtain our first row, then we'll obtain our second row over here. And if you want to change its axis, that means the default value over here is of C. And if I write F inside it and run it, it would give me in this way that 2, 1, 4, 3, 6, 5, 8, 7. So you can see we have obtained 2, 1, 4, 3, 6, 5, 8, 7. That means we are going vertically over here. Similarly, for horizontal, the default value is C. So if I want to get it back as C, so it is a default value as well. So if you don't provide anything, we have C over here. And if I want it to go vertically, in that case, we need to write F over here. So now if I have written C over here, it would give me 2, 4, 6, 8, 1, 3, 5 and 7. That means this row first, then this row. Otherwise, if you write F, then in that case, you obtain it column wise. That means 2, 1, 4, 3, 6, 5 and 8, 7. So this is how our flatten works. Now let's move ahead and talk about our sum function. To write sum, we will be writing print n.sum, and if I run it, I'll get the output in this way, that I'll obtain 36. So it would give me the cumulative sum of all of them. That means it will add all of them, 2 plus 4 plus 6 plus 8 plus 1 plus 3 plus 5 plus 7. While at the same time, if I want to define an axis over here, so if I write axis is equals to 0, axis is equals to 0 means that I want to find sum vertically. In that case, if I run it, I'll get the output 3, 7, 11 and 15. That means 2 plus 1 is 3, 4 plus 3 is 7, 6 plus 5 is 11 and 8 plus 7 is 15. Similarly, if you want to find this sum horizontally, in that case, you will be writing, instead of 0, you'll be writing 1 over here, and as soon as we run it, we'll get the output 20 and 16. The 20 is the sum of the first row, that is 2 plus 4 plus 6 plus 8 is 20. And our second row over here is 1 plus 3 plus 5 plus 7. Okay, this is how our sum works. But what if we have a null element over here? That means not a number element over here. For example, if I have np.nan, np.nan means not a number element over here. If I run it, I will get the output as, so for this one, I'll get 2, 4, 6 and nan and 1, 3, 5, 7. If we'll try to find the sum over here horizontally, so let's just ignore this part. So I'll just remove this one from here. Okay, if I run it, let's just talk about the sum part only. So if I obtain the sum for, if I talk about the horizontal elements here, for 2 plus 4 plus 6 plus np.nan will give us nan, because it won't number over here. In that case, what we need to do, we need to write nansum. So if I write not nansum but nansum, and now if I run it, so for that I also need to write np.nansum, and I need to pass n here, put a comma and define my axis is equals to 1. So np.nansum function, and what whose nansum function we need to find? We need to find it for our n array, and the axis is 1. Axis 1 means horizontally we need to find it. So now the output would be 6 plus 4 plus 2. for the first row and 7 plus 5 plus 3 plus 1 for the second row. So if I run it, I'll get the output 12. 12 means 6 plus 4 plus 2 is 12, and it will count this as a 0 element. And for the second one, we will obtain 1 plus 3 plus 5 plus 7. Similarly, if I talk about vertically, if I want to go vertically, in that case, I'll write x's is equals to 0. And if I run it, it would give me 2 plus 1 as 3, 4 plus 3 as 7, 6 plus 5 as 11, and p.nan, that means 0 plus 7 as 7 over here. This is how nansum work. Similarly, if I talk about cumsum over here, for cumsum, what I'll be doing, I'll be just putting this inside the comment, and here I'll be writing print np.cumsum, and cumsum I need to find the cumulative sum of n, and if I just run it simply, it would give me a value like this, 2, 6, 12 and nan. So let's just remove nan from here, and I'll just give any other element like 8, and if I now run it, so it would give me a value like this, like 2 is my first value, 2 plus 4 is my second value, 2 plus 4 plus 6 is my third value, 2 plus 4 plus 6 plus 8 is my fourth value, that is 20. 2 plus 4 plus 6 plus 8 plus 1 is 21, plus 3 is 24, plus 5 to all of it is 29, and plus 7 to all of it is 36. Now if you want to define the x's over here, what you need to do, you need to write axis, x's is equals to 0. So first of all, let's go vertically. For vertically, if we want to find the cumsum vertically, we'll be getting the first row as the same, and the second row will be the sum of the second row plus first row. That means vertically it will find the sum. So 2 plus 1 is 3, 4 plus 3 is 7, 6 plus 5 is 11, and 8 plus 7 is 15 here. Similarly, if you want to find it horizontally, in that case, you will just write 1 over here, and if I run it, I'll get the output as 2. The first value will remain 2. The second value will be the addition of 2 plus 4. The third value will be the addition of 2 plus 4 plus 6. The fourth value will be the addition of 2 plus 4 plus 6 plus 8. Similarly, if I talk about the second row over here, the first element will remain the same. The second element will be the addition of first and second element. The third element will be the addition of first, second and third. And the fourth element is the addition of first, second, third and fourth. In the same way, our cum product works. So if I put this inside the comment, and if I write print cum product, means that it will give a cumulative product over here. So np.cumprod, and here I'll be passing n inside it. Along with the n, you can define the x's. So if I don't define x's, if I put it as default, it will flatten the array and then give us the output. That means it will be like the first element is 2, the second element is 2 multiplied by 4, third element is 2 multiplied by 4 multiplied by 6, then the next element is 2 multiplied by 4 multiplied by 6 multiplied by 8. Again, next element is the multiplication of this multiplied by 1, the multiplication of the previous value multiplied by 3, then next value would be 2 multiplied by 4 multiplied by 6 multiplied by 8 multiplied by 1 multiplied by 3 multiplied by 5, and last value will be the multiplication of all the numbers that are there. This happens when we have not given any x's over here. So if we define the x's, in that case, if I write x's is equals to 0, first of all, let's go vertically. So if I run it, it will give me the first row as the same. That means the first row is 2, 4, 6, 8, and the second row is 2 multiplied by 1, that is 2, 4 multiplied by 3, that is 12, 6 multiplied by 5, that is 30, and 8 multiplied by 7, that is 56. And if similarly you want to put the x's as 1 over here, in that case, if I run it, I'll get the output horizontally. That means the first element will remain the same. The first element over here is 2. The second element is 4. So that means 2 multiplied by 4 is 8. Then 2 multiplied by 4 multiplied by 6, that is 48. And 2 multiplied by 4 multiplied by 6 multiplied by 8, that is 384. Similarly, if I talk about the second row over here, the first element remains the same. The second element is the multiplication of the first two elements, that is 1 multiplied by 3. The third element is the multiplication of the first three elements, that is 1 multiplied by 3 multiplied by 5, that is 15. And last element is the multiplication of all the four elements, that is 1 multiplied by 3 multiplied by 5 multiplied by 7, which gives us 105. So I hope guys that the cum product is also clear to you and you have no doubts in the questions. So these are some of the functions that we have covered. So I will also include print n.sum to it. So these are some functions that we have talked about. Our first function was flatten, which would flatten our two-dimensional into a one-dimensional array. Next function over here is sum, which will help us find the sum of two arrays. Suppose if we have two arrays and if you want to find the sum, whether it's vertical in axis or horizontal in axis, totally depends on us. And if you want to find the sum, then we use the sum function. Nansum is used when we have a nan value inside our arrays, and then we had cumsum, which will give us the cumulative sum along with the axes. And then lastly, we had cumprod, which would give us the cumulative product of arrays over here. So I hope guys that all the functions that we have covered in this session is clear to you. In our next session, we will be talking about more functions that are there in our Numpy. So stay connected guys, and I'll see you in the next session. Thank you.